Hello and welcome back to yet another episode of Matrickz Tech Talk. Today, once again, we have Alex. Alex is working for a German Tier 1 company. He's building smart vehicle subsystems and he's very passionate about autonomous driving. He's also driving a group called Detroit Autonomous Vehicle Group, where he is working with small projects to build autonomous vehicle. Alex, welcome back to Matrickz.
Hi, Hasan. Thank you for having me.
And our second guest today is also a very special one. Sharan, he's involved with IEEE local chapter. He's the vice chair of the IEEE local chapter in Detroit. Is it Detroit or Auburn Hill?
No, Southeastern Michigan.
Southeastern Michigan. So it's a much larger scope than Detroit. And he is also in charge of the local education of IEEE. He's a very passionate engineer. He is passionate with high performance engineering, and he's going to talk about high performance engineering today. Sharan, welcome to Matrickz.
Glad to be here.
So before we begin, I'll start with Sharan because you're the first time in our podcast. So I'll start with you. Can you tell our audience a little bit about yourself, your passion, and your background?
Well, certainly. Let me start with the passion first. My passion is high performance computing, and I've been in that industry for quite some time. I've seen it grow and become mainstream. As a matter of fact, Alex mentioned machine learning, and that kind of came out of high performance computing. Many technologies that have become mainstream came out of that, and I continue to work in that and expand the boundaries. And then you had mentioned IEEE, so I'm with the local computer society chapter, and we do a lot of things to bring both young engineers, students, and professionals together and remain in touch with a lot of technical issues that face engineering today, computing today. And it's quite a large group. We're a total of about 3,000 engineers in IEEE in Southeastern Michigan, out of which more than 15-20% are involved with computing. And of course, being in the, heart of the automotive capital, a lot of us deal with automotive and mechanical engineering issues as well.
Fascinating. Thank you so much, Sharan. So for our audience, Alex, who haven't seen the previous episode, can you introduce also a little bit about you and talk about your passion a little bit?
Yeah, absolutely. So come from a family of engineers, of computer science engineers, mechanical, civil, all kinds, aerospace, including Yuri Gagarin's. My grandma did some work on Yuri Gagarin's first space flight. And so I've always been around engineering, and so I naturally gravitated toward it. At a very young age, I got into cars through my grandpa, who was involved in automotive during World War II and so on and so forth. And then we moved to the United States when I was about 12 years old. And we moved to Silicon Valley, where my dad has always been a software developer. And so we kind of put the passion for cars, and then you put, family of engineers and software developers, you naturally end up with, it used to be video games, and now it's self-driving cars.
Fascinating.
And so I've always been in that, and it's been my passion. And so it's, I try to work on top-notch technologies and leading technologies in the automotive space, and some of it is, enabling people and then also making smarter products that can serve the world, hopefully the world or the people, the user, more and better.
Fascinating. So you already mentioned autonomous vehicle. Yeah, I mean, this is something that we want to talk about. It's a rare occasion that I have two individuals, very, very distinct individual who has a lot of insight. One, Sauron is running the IEEE chapter, which is fascinating. He can talk a lot about it, and your passion is machine learning. You build intelligent vehicle subsystems. So now we're at the dawn of an era where we will be seeing connected vehicles, we'll be seeing autonomous vehicles, and naturally electrifications of vehicles. So with these two, I have a question to both of you. From a machine learning perspective, when you build an intelligent system, Alex, What are the hurdles that you see at this point? Where does the industry stay today? And to Saran, how do you think high performance computing is going to play a role in the development of autonomous vehicle?
Alex, you go first. Yeah.
So I think some of the hurdles that I'm dealing with now actually is even though computing power and maybe Sharan can help push this forward a little bit more, is vehicles they're embedded systems, so you don't, at least today right now, you don't have access to these huge servers and these huge computers. And so the computing power, especially with smaller subsystems, so if we talk about maybe a body controller or an engine controller, those are slightly bigger. But if you talk about a window regulator, those are much smaller microcontrollers. They are maybe 16-bit, probably a lot of them are 8, with 512 KB or maybe MB of RAM. And it's not a whole lot of computing power. And so getting machine learning to deploy on the edge, we're still just starting to get there. And so actually neural networks are very difficult to deploy on these small microcontrollers. And so some of the challenges we're tackling is, how do you do that? What approaches do you take, and what computing methods can you use to make smarter subsystems on that smaller level? So I think today, again, some of the computing power is still not quite where it could be. Or maybe the other way is connectivity, also like the cybersecurity and building connected cars so that you have access to the outside. And so you can do, now we're getting into the over-the-air updates and things of that nature, but it's still not where it needs to be. The connectivity to outside the vehicle is still, there's a lot of challenges that lie ahead of us. But once that opens up, that can really open up a lot. It can give you kind of free up your hands and give you a lot more computing power, give you just a lot more functionality, and really enable the vehicle to do a whole lot more.
I agree, and that kind of like builds a segue towards Saran, as you mentioned that you don't have enough computing power for the neural network, so you train the neural network in the back end, and then you flash the learned model in the ECU. Is that the way to understand?
So yes, that's one way. So you deploy an inference, you can. And then, for example, ARM built more efficient kernels not too long ago for their small, like M4 microcontrollers. But our microcontrollers are even smaller. So actually, we're working with some companies who have developed new methods such as greedy adaptive detection. And we're actually looking at not using neural networks, but using other methods such as sparse coding to build these models that we can deploy inferences of on the embedded system.
So no matter where you train the data is trained in the background. Is that a safe assumption? So with that, to Saran, how do you think high performance computing can actually contribute to this hurdle that Alex just mentioned?
Well, when you say contribute to the hurdle, I think you mean contribute to
the solution of the hurdle. You're right. Yeah, I like that.
Well, you mentioned 3 areas. You mentioned, like electrification, you mentioned connected vehicle, and autonomous driving. So high performance computing has continued to make strides, and the way things are going right now, all the things that we've learned, the hardware architecture, the software architecture, we are now having much smaller hardware physical systems that can fit in the vehicle and have all the horsepower that's needed. But in all these 3 fields, what I see the challenges is the software programming. That is a massive, massive challenge. And we can provide even more horsepower. We have a timeline. We're getting to the point where we are having exascale systems over due course of time. A fraction of those will be available in small packages that can go into automotive systems, no doubt about that. But the challenge will be software. Let's take autonomous, for example. It has to coexist with humans around it and react to many situations, which mean we'll have to continue to add more boundary conditions, special things, rules and regulations are still being formulated. So it'll be a constant evolution. And therefore, updating the software, testing the software, validating the software is a big challenge. So I see tons of activity there. And the more compute horsepower we provide, it will help in improving reaction time, response time, talking to connected systems. So that's a positive. But the programming challenge remains. It's, you can make many software subsystems, but then have them all combine and integrate together. That'll be a work cut out for everyone who's involved in this across the world globally. So that's about autonomous. When it comes to connected, clearly, cybersecurity is a big deal out there, and they'll need all the horsepower they can get so that they can always scan for constant threats, validate stuff, and make sure that whatever is put in and updated is the latest and greatest and can react to that. My personal view is that we'll see the greatest progress first in electrification, because there the challenges are much more finite. Yes, battery technology has to improve, and it will improve over the next several years. But then, no matter what, it's energy stored that has to be converted into kinetic form, means moving the car forward or backward. And we have to manage the energy stored. So there'll be tons of controllers or algorithms that will manage the battery, keep track of it, alert us to charge it up, and take care of issues. If many of the cells misbehave, then it can actually route around it. So there it's much more tractable, and I think that's where we'll make the greatest progress towards electrification and energy management with high performance computing, providing the horsepower and manageable software challenges. So I've outlined a pretty big landscape out there for you.
A couple of years ago, I forget about autonomous vehicle. A couple of years ago, I came up across statistics in which field do we have the highest number of lines of codes. And surprise, surprise, it turned out to be automotive. I mean, the one reason was we write in C. That was one reason. So our coding are intensive. But when it'll go to adaptive AUTOSAR and very much machine learning, I think this complexity is going to explode. So integration is definitely a challenge. Alex, what do you think from your point of view? I'm coming back to the energy management and other topics in a bit, but let's talk about this software integration. The complexity is exploding. This is not getting any better. We're adding abstraction layer on top of abstraction layer, and end of the day, what we feed to the machine is the assembly code, which is ginormous. So what's your take on that, Alex?
So we try to, for that reason, we try to take new approaches. So everybody always, when you talk about machine learning, it's always neural network. And then so there's a lot of these networks have already been developed and invented by researchers, but you don't necessarily need all the nodes. You only need what you need. And so they're actually, to Sharan's point of saying, where a lot of it has to do with code, right? So you can take kind of two approaches. One is you increase the computing power. The other, you write more efficient code. And so actually, it's kind of like where my group comes in a little bit. So we founded the group, and then the reason we stay with small computers no bigger than Raspberry Pi is so that we kind of forced ourselves to write more efficient code. So instead of getting a bigger computer and then just writing whatever, having a whole bunch of loops that don't need to be there, and all sorts of functions that don't necessarily need to be there. We try to force ourselves, by limiting the computing power, to only write the code that we really need. And so we try to take new approaches and come up with things like, sparse coding and stuff like that for machine learning. And so it's not always about neural networks, and we try to find these new methods and more efficient ways.
Allow me to add a little bit, how should I say, aura of realism to that. It's good to target sparse code, but remember, this is an evolving field. So new features or new cases or new problems will have to be solved then you'll have to integrate it in it. If you make very tight code, then it makes it more difficult to add new features and then test them. So if we recognize right now that whatever we have, it has to be updated constantly and new features added, we should structure it so that these things can be added more easily and in a timely fashion. And of course, without issues. And what comes to mind is something we should borrow from Agile methodology, that they recognize there'll be more features added, so they design it in such a way so that it's compact, efficient, but easy to add features as we grow, evolve in this field. And then the last thing I wanted to do was add a little bit about, you talked about lines of code. A modern day aircraft, like, pick any one, is anywhere between 10 and 20 million lines of code. But the latest Mercedes model high-end luxury car has 100 million lines of code. So clearly, there's a 10-to-1 ratio, and it's easier for the aircraft. They only have to worry about a few things up in the air, but on the ground, the car has to worry about pedestrians, people, traffic, all sorts of stuff. So it has a much more challenging job.
So, I mean, with that, if you say 100 million, at that rate, I think I won't be surprised if we hit 1 billion line of code. And the complexity would increase. And I think that goes hand in hand with also energy management. I mean, if you have electric vehicle, we have to be very efficient. It's not about lines of code, it's about also energy management. How do you think we can tackle that problem? Along with, you also mentioned Agile, so I have a very interesting question on that. I'll come to that after we cover the energy management bit.
So the energy management challenge is pretty complex. Right now, I know several groups all across the world, both energy, battery makers, as well as people in the controller field, and then OEMs, vehicle subsystems. They're all seized of the problem. They are working on it, and they're coming up with more algorithms. However, algorithms themselves draw power. So they have a very fine balancing act. Clearly, what I think is part of Alex's approach is to have there. I don't think we need too many new features. There we can be compact and efficient. And there I expect newer computing hardware can deliver that same management storage, but at a far smaller energy fraction cost. So that's where I expect to see complexity will be there, but not as bad as the other fields like connected or autonomous. So that's why I said I think we'll see the biggest growth in energy management, both in the hardware subsystems, the computer, the software, etc.
And Alex, what do you think about battery power? Because remember in Auburn Hill, when we sat down together, we talked about this issue, and Sharon really had a lot of interesting points. So I want to revisit that topic. But that was really, that was a nice time we had. So can you talk a little bit about the battery power and what do you think this will play a role in the entire development?
Yeah, Alex, that was for you.
That was for Sharon, right?
Oh, that was for me.
I'm open. Whoever wants to take it.
Well, as I mentioned when we first met, if you look at it, battery technology hasn't changed a whole lot for the last 100 years.
Yeah.
It's still based on chemistry. Okay, we had lead acid, then we had nickel cadmium, now we have lithium ion, but it's still chemistry. What we need to do is, I think, if any of those listeners out there would like a challenge and be recognized in the world for it, is to think outside the box and look for how does nature provide energy? How does it store it? How does it capture it? Look to beyond chemical systems, which, like I said, hasn't changed for the last 100 years. That might be a big game changer, or not just automotive or engineering, but the entire world. I think I'd like to throw that interesting challenge out to all your listeners to think about new ways of doing battery technology beyond the chemical model that we have today.
I have a question for Sharan. What about Fisker? Are you familiar with the solid state battery that they're developing?
Yes, I'm familiar with that, and I completely applaud at least their thinking.
Could you please elaborate what you just mentioned for the what is that for the audience?
I'm curious. I don't know as much about battery technology, but I'm curious. I think Sharon has a good point. Tesla partnered with Panasonic, years ago to try to speed up the development process, and it hasn't really happened the way that they envisioned it when they created the partnership. And so you're absolutely right. Batteries, energy, and so there's fuel cell companies such as Bloom Energy out in the Bay Area. Actually, when I worked at NASA, I worked in the same lab as the founder of Bloom Energy. And so they're taking companies off their grid. They use hydrogen fuel cells basically to generate electricity. And so companies such as Coca-Cola, Google, they are using their technology. But then also, as of last couple of years, Fisker has really been promoting their new solid state battery technology. And so I was wondering what Sharon's take is that, thinking outside the box?
Yes, it is thinking outside the box. And, I applaud such efforts. Solid state fuel cells, there are tons of technologies that have potential. The only way we can realize that potential is somebody has to actually try it. I don't know if you've heard of the saying, but Edison, when he came up with the light bulb, was asked at a press conference about it, and he said he tried about 1,000 different ways. And someone said, "Why did you do 1,000?" He says, "Because I figured out 999 ways that don't work." So we have to do the hard yards. We have to really break ground and try new things. That's what the folks 100 years ago did when they came up with the battery. Before that, we had no energy storage. It was maybe water that you let it flow and it turned the water wheel and things like that. So we have to explore. This is a great time to do it because we have so many technologies out here. The world is also connected. You can, like us, correspond. You can tap ideas, minds. So this is a great time to do it. And renewable, solar, other things, miniaturize those so that they can provide the power. Come up with storage to complement that. Then you could have power during the time when there's no sun. Everything is possible. Just think outside the box.
I agree. So I'm moving a little bit toward other topics as we mentioned during our discussion. One was, Sharan, you mentioned security. Alex, you mentioned over-the-air update, which will be necessary in the future. And Sharan, during your discussion, you also mentioned in software, we need to go agile. So I'll start with agile. As we know, you both have worked in the automotive industry. Automotive industry, at least in Germany, as I know it, it's very traditional. We are very much legacy process driven. Tell our audience a little bit about your experience with this legacy automotive process and agile. Did you face any challenges? How did you solve it?
Well, clearly there's a difference between the two, and a lot of this came from the West Coast and the high-tech industry, where they figured out what you call legacy. We call it the waterfall method. Where
exactly, precisely, yeah.
Come up with all the requirements at once, set them in stone, and then years later come out with the product only to realize that market has changed, conditions have changed, and what they thought were the requirements was not exactly what they wanted. Because then after 2 or 3 years, they said, well, this is not quite, and what has happened is time, money, resources have been lost. So if I think about maybe the browser industry, which is something most listeners would relate to, or they would have updates maybe every 2 or 3 weeks, but with one tiny feature or maybe just one major feature added, slow and incremental each time. And that was the Agile method. In Agile, you pick 1 or 2 things, develop towards that, recognize there'll be other things along the way, so you leave a structure behind so you can add, subtract things, then release it in the market. Number 1, it's compatible with what's out there, You made small changes, and then people get to experience those changes, and then they say thumbs up or thumbs down. Then they can take it away and replace it with something else. But you're doing one or two changes at a time. That's more manageable. You can get it out the door quicker, hence agile. And then it'll actually, what you have after a series of incremental deliveries like this, quick, short time, you actually have a product that everybody likes and said, that's what we wanted, or we didn't realize it, but as we went along, now we figured out. And it's always continuous improvement. So it worked for the Japanese in their manufacturing continuous improvement. And now the software industry is adopting it. That's what I would like to see be more pervasive, so that we can use agile methods to deliver pieces of what we need, so that over time we get what we want.
Fascinating. Alex, any point to that?
Yeah, it's very tough and very painful. So, I mean, I know the agile methods. I'm somewhat familiar with them. I don't use them for the reasons that you said, that automotive is very traditional. We currently don't really use agile methods to develop products that we're launching today. So maybe there's teams that are trying it out on some prototypes or something like that, but nothing right now, at least in the things
you're right. You're right.
Yeah.
I would add that at least here in our part of the world, General Motors, Chrysler, Ford, they have small groups that are trying the agile method. They're having some success, and they learn along the way as well. So we'll see more of it in the future.
But it's hard. It's hard because the companies have so much.
You have to change your mindset.
And you have to change the mindset, which is really difficult. And then you have to change basically what the companies have done for hundreds of years. You know, an old company in Silicon Valley is Google. How old is Google? 20 years, I think they just celebrated like 2 weeks ago. That's like a dinosaur. But then if you look at, 20 years in Detroit or automotive industry is like nothing. And so we're talking about companies that have been around for 100 years, and now we're like, hey, well, let's get agile. And it's like, well, we're 100 years old. We're, it's a little bit hard to
change is hard.
I find one argument quite legitimate to one-to-one adopt the Silicon Valley agile culture is, there's this notion of minimal viable product, an MVP in Silicon Valley. And Sharan, you rightly mentioned the browser development. But in automotive, minimum viable product can be fatal, right? I mean, you have to have some certifications. So now moving back to the over-the-air update scenario you mentioned, here is one problem that we're facing right now. We have ECU software that has been safety certified, very rigorous certification process. Now I'm shipping over-the-air update. Now, this delta can affect the entire code. I mean, everything theoretically has to be recertified, but that's a big challenge. Are you facing similar challenges in your work, and what do you think would be the solution for such challenges?
Well,
simulation.
Yes,
High computing.
Very natural answer. In order to, recertify these things, we've done it with vehicles through crash simulations and high performance computing, to the point that many governments and official regulatory agencies accept simulation results for crash and safety. There's no question about it. Of course, they have to demonstrate it, but once demonstrated, they've now continued that progress. And I do believe that simulation is the best way. New over-the-air updates or any kind of thing, whether it's for electrification, connected, they all can be subject to a simulator. The airline industry does that. And when they cut corners, then they run into trouble. That's why simulation and high-performance computing is definitely a solution, if not, the best solution, but it is definitely a solution that they can run these through rigorously for all known conditions and even add new conditions out there so that they have a high degree of confidence and reliability and all that.
What I want you to talk about is we talked about Overtheair update, the security aspect. Sharon mentioned during his part. How do you think security will play a role here?
Well, security will clearly play a role, maybe even more important than features, electrification, or autonomous, because we have to win the public trust. So we need to have an approach to security that's transparent, above board, and solid and reliable, and then actually put out data out there so the public can say that, yes, we like it, we agree with it, and this is how they'll handle it. And we also need industry agreement on that. That'll help a great deal.
Alex, Sharan, it was lovely having you. Thank you so much being in Matrickz Tech Talk, Autonomous Vehicle Safety and Security podcast. Thank you so much for watching, viewing our podcast, listening to our podcast, liking our podcast. If you have questions or comments, please write below or write to us at podcast@matrix.de. We'll be more than happy to answer your question. So today we had Sharan and Alex in our podcast. I hope to see you again in the podcast. And thank you again for joining.
Always fun to chat. Thank you, Hasan.
Thank you. Have a good day. In this podcast show, we bring in the industry leaders and experts in the automotive domain to share their experiences along their journey. The mission of our podcast is to start a dialogue that will allow us to understand the development of automotive industry and where the automotive industry is going. You can ask questions to our guests directly. Just send us an email to podcast@matrix.de. We'll schedule a call with you during the recording and you'll be part of our show. Make sure you subscribe so that you don't miss any new episodes. Please share this video to help others get enlightened as well, and that would mean a great deal to us. See you in the next episode.